Hello, hello. Let's dive into the ADVizE mini lecture, types of data and why we use them in teaching. I'm Kristen Hunter Thompson. So first, let's reflect back for you and what you've been using. What data have you used so far this semester? How was it collected? What did you use it for? What kind of data was it? Okay, pause the recording, think about that a bit, and then come back. So there are different ways that we collect data or that data are created. We've got learner generated data, professionally collected data. We're going to talk about those in just a second. There's also local ecological knowledge and traditional ecological knowledge are two other important ways that data are collected or created. Local ecological knowledge is if you have been going out fishing with your parents and your grandparents in a certain location, or even just you and your parents for a long time to the similar place. And you know that if the wind is coming from a certain direction, and if it's a certain type of day with the sunlight hitting in that direction, if you go to this particular spot off the shore, then and drop your line, you're going to be able to like fish and hook in a certain kind of fish. You're definitely using data, you're using your lived experience of that ecosystem and how that interacts. That is local ecological knowledge. Traditional ecological knowledge spans multiple generations, multiple time scales, and multiple spatial units. And so from living intimately with a space over multiple generations and tracking all the interconnections, both direct and indirect, in the system allows you to have the understanding that depending on what the snowpack level is in the winter in the mountains will influence the amount of runoff in the spring, and therefore the temperature and the extent of the fresh water in the river, which will influence the timing of the salmon return and the success of the salmon as they're coming upstream to spawn in the fall. So multiple timescales, multiple different spatial scales are involved in traditional ecological knowledge. It comes from living intimately with the land. There are less spaces where traditional ecological knowledge and local ecological knowledge show up in our K-12 space, but they are very important ways that data are collected and created. We'll dive a little bit more into learner generated and professionally collected because those do show up often in the K-12 space in just a moment. One thing that I want to say is as you're going out and looking for data that other folks have collected, there's a sort of nomenclature on how we organize things online. And this just 100% has to do with organization. So things that are labeled real or near real-time data are things that often have been collected in the last 30 days, though this is industry dependent. And then we shift things over to be archived data, often when it was collected more than 30 days ago. So today, when something was collected 29 days ago, it would show up as real or near real-time data. Tomorrow, when it's over 30 days, it would show up as archived. The data is exactly the same. It's just an organization capacity thing on servers. But let's dive into this learner-generated versus professionally collected data. So learner-generated data has some amazing benefits of a learner understands where the data comes from. They physically collected them themselves. Therefore, they have a better context of the question and the data at hand. They have this personal connection to the data, and the data sets are small because there's just only so much time in the day that we can spend collecting data. This is really helpful for our learners as they're starting to work with data. But there are some key limitations to learner-generated data as well. You're limited in the time and space and the kinds of questions that you can ask. You cannot ask questions at the microscopic level because you can't collect those data. You cannot ask questions on the geologic timescale of epochs because we cannot collect data across those time spans. It's also really time consuming to collect data. It's a lot of precious time goes into collecting that data, and it is not always consistent in the collection or the protocols. So Kim Castens and colleagues have done some work to think about okay, so just what is the learning curve? to move from sort of unstructured observation with human senses. I walk out the door, I see what the temperature is outside, that determines what clothing that I will wear. My third grader is working on this right now. So there's a learning curve with that, right? We get better with that over time. But then there's a challenging transition to move from that to student collected small data sets. These are both examples of learner generated data, but there's a big inflection point. There's a big transition point here to go from these unstructured observations to more structured, consistent, student collected small data sets. So what about professionally collected data? And I put citizen science into the professionally collected data column because professionals have set the protocol and they're often the ones using the data, even though communities or citizens are collecting the data for those professionals and could be using them themselves. So there's some great benefits. It expands the temporal and spatial scale of questions that we can ask. We know that the collection has been consistent in terms of following consistent protocols. And because we've taken the time away from the collecting, we just have to access it, which is a thing, and no joke, I'm not going to lie there. But once we've accessed it, then we can put more time towards analyzing and interpreting the data. But it's not rainbows and unicorns. There are also some real limitations. It can be hard to find the data that work or that are relevant or that are appropriate for our learners. It can be hard to access or understand. It's been collected by scientists and engineers for scientists and engineers, not, for example, our second grade students or our fifth grade students or our seventh grade students. There can be a lot of noise in the data. Dun, 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 dun. Variability exists. It's a real thing and it exists there. And it doesn't always show clear patterns because the real world doesn't always show clear patterns. Even when in professionally collected data sets, we know every data value is a valid data value because it has been checked and confirmed that it was not, say, user error that went into creating that value to create that data point at the value that it is. So we can go back to the work by Kim Castens and her colleagues and think about, okay, continuing thinking about this learning curve. There is a learning curve when we're working with professionally collected larger data sets around a well-structured problem where we're posing the problem for our learners. There's definitely a learning curve there. And there's another one of these like challenging transition points where we get to working with large professionally collected data sets where the students are leading. It's a total open inquiry, and they are leading the way on what we want to do. Now, Kim and her colleagues put another challenging transition point here between learner-generated and professionally collected. I would make it even steeper. And the other thing that I would say is that this is not a linear progression. You do not need to master learner-generated data to work with professionally collected data. In fact, these overlap. Our youngest students should mostly be working with learner-generated data. Our older high school students should be mostly working with professionally collected data because of all those benefits we discussed. But our upper elementary, middle school, lower high school, there is overlap. We can be working with both learner-generated and professionally collected data at the same time. So let's think about ways that we use data. So we can think of it on a spectrum from we use data to understand what is already known. So if we are learning about hurricane tracks and understanding where hurricanes may go in general, we could use some data to think about that. If we are learning new discipline knowledge, if we're generating new discipline knowledge, if nobody in the world knows this yet, we are going to use some data to better understand what is happening in the system, how the system works, why the system works, where we're seeing different things in the system. So this is not new to the learner, this is new to the world in terms of ways that we use data. We can also think about the types of data that we use. One type of data are simulated data or idealized data. These data are sort of representations that have been manipulated, and when you hear manipulated, think of like have been purposely put together to clearly emphasize or demonstrate a particular scientific concept with minimal confusion. Textbook graphs, diagrams, when we are modeling theory of how a system works. So what's an example? Plate tectonics. When we draw the lines of the plate boundaries, this is simulated data. So pause the recording and brainstorm a second. Just think of like 5 benefits and 5 limitations for using simulated data in your teaching. You can think about here with plate boundaries, or you can think about something else. Let's make it 3. 3 benefits, 3 limitations. Okay, once you have them, come back, turn the recording back on. So simulated data is one end of the extreme. What would be the other end of the extreme in terms of types of data? Well, that would be raw or real world data that's collected using instruments, equipments, models to investigate a question. So for example, here, using our plate tectonics, here's an example of raw data and simulated data, because I kept the plate boundaries in there for you. But each one of these red, orange, and green dots represents a geologic feature, a data point that geologists use to identify where the plate boundaries are. Okay, so again, pause the recording and think about 3 benefits, 3 limitations of using raw data in your teaching. You can either think of this particular example or just more generally. Okay, welcome back. So we've got real world to data of idealized or simulated. And then we have the why, the ways that we use it. We use it to understand what is already known, and we use it to generate new knowledge for the world. So we can think about this in terms of how data can show up in our teaching. So if we're in this bottom left-hand quadrant, we are using data of idealized patterns to understand what is already known. This is where a lot of our textbooks or lesson plans live. In the upper right-hand quadrant, where we're using real-world data to generate new knowledge for the world, we can think about this is when we're doing field work or lab bench work, where we're modeling with data out in the real world. Professionals, when we are looking at data of idealized patterns to generate new knowledge for the world, this is where we can model theory of understanding of how the system works that can then be, can build up and inform what we do in the field. And when we're using real world data to understand what's already known, this is where a lot of our data-based activities fall into our teaching, into our classroom. So it can be helpful to sort of think about that in terms of the types of data we're using, idealized to real world, the ways that we're using data from what's already known to generating new knowledge from the world, the ways that we collect data from learner generated to professionally collected data. They all have benefits and limitations. And the key thing is to think about, okay, so what do I want to have happen for my learners in this particular instance? And then how that threads throughout the whole year of exposure for our students. So the reflection here for this mini lecture is to pause. First, think about how do these ideas connect to what you already know? And then extend. What new ideas extended or broadened your thinking about types of data and incorporating data into teaching? 3, what still seems challenging or confusing about what types of data to use or how to collect the data or ways that we would use the data? What questions or wonderings do you have? And then 4, what 1 or 2 things will or could you use in your teaching going forward with data to apply these new ideas or understandings? So pause the recording, think about your connect, extend, challenge, and apply. As always, thank you so much for what you do, for participating, for all that you're going to bring to your learners going forward when it comes to data. I'm so excited to hear how it goes. Reach out with any questions you have now or in the future. Happy to help. Thanks so much. Have a good day.